Yeah, how many people attempted last problem? Okay. And how many solved successfully out of you? Okay, Madhusudan solved. Kumar, Yashwant, you also solved, completed this problem. Okay, after the contest, Yashwant solved. Okay. Okay, Yashwant joined late. Cool. So let's hear from Madhusudan. Madhusudan, what was your idea?
So like to basically divide nums divide whole, like we have to divide every element of nums divide, na?
Okay.
So we should take the GCD.
Fair.
Yeah. So after that, like we have in the nums, we have to check for either GCD is present or a factor of GCD is present, which is like smaller than the GCD.
Absolutely.
Yeah, that's the whole thing, and we just have to code it.
Fair, awesome. Yashwant, what was your idea? Okay, same idea. Yeah, guys, so we are trying to find out how many numbers we will have to delete from nums array so that the smallest number that is available in nums array divides every number here. Now, if you just focus on this array, what is a number that can divide all the numbers of an array? If you want to find a number that can divide all the numbers in this array, that number in this example is 3. And what will be special about that number? Because what will be special about that number? For example, if I ask you, if I give you a few numbers here, let's say I'm giving you 21, 35, 105. Can you tell me a number that divides all of them? Any number that divides all of 3. Okay, 7 divides all these 3. Okay. Now, if I give you another one, let's say can you give me a number that divides all of these numbers? Yeah, so 5 is a number, 25 is also a number that will divide all these numbers. Now, special thing about 5 is GCD of all these numbers, which is greatest common divisor. Same way, 7 here is a GCD of all these numbers. Okay, since we are talking about divisibility here, the point is, first of all, finding out what number will divide all these numbers. That can be done as finding GCD. Now, GCD is a standard algorithm. Many languages have GCD function built into the language. So if you want to find GCD of 2 numbers, usually built-in function is available in every language, or there is a standard Euclidean method that you have to keep on doing modulo of one number with another, and you can find GCD. And during contest, many people use built-in function, which saves time. Sometimes you can quickly take the template code and start using it because it is a standard algorithm. Now let's say we find GCD of this. I take this example here, the second example that we are having. Let's say, and our array had numbers 2, 3, 5, 6, 7. This is our nums array. Now, if I ask you a question, if you find GCD of all of these numbers, if you take GCD of these two, it will turn out to be, in fact, GCD will turn out to be 25 from this array. Oh, no, it will turn out to be, if you're finding GCD of 2 numbers, then of course it will turn out to be based on those 2 numbers because 5 is not in picture. For these 2 numbers, GCD, greatest common divisor, essentially for all these will turn out to be 25. Do we agree with that? The GCD of these will turn out to be 25. Because when you take GCD of 200 and 125, what we do is 125 ones are 125 and we are left with 75 here. Now you take 75 and you keep the smaller number here, which is 125. 75 ones are 75, we get 50. Then we take 50 and we put 75 here. 51s are 50 and the remainder is 25. Then you do 25, you take 50, 22, 25 twos are 50 and it becomes 0. So whatever number reduces things to 0, that is the GCD. So if you take GCD of this entire array, it will turn out to be GCD of these two numbers is 25. Now you take that 25 and do a GCD of 25 and 225. This will also turn out to be 25. Now if 25 is the GCD of this array, then how many numbers from the nums array you will have to delete so that the smallest number can divide all these numbers? How many numbers should we delete from this array so that smallest numbers out of leftover numbers in this array divides all the numbers? We'll have to delete 2 numbers. Can we say mainly now we are in search of a number in this array which is GCD of that number and GCD of this entire array? That is what we have to search for. Is that correct? So we are trying to find a number. It's like a find smallest number X in nums array such that that smallest number X, comma, this GCD G, GCD of both of these should be equal to what? GCD of this and that number should be X. If that be the case, if we can find index of that number, and here that number's index is 2, that means those many deletions have to be done. Right? Okay, so it was all about finding GCD of this array. And then in order to find smallest number here, will we sort this array? Should we sort this array and then find GCD? Yes. Yeah, sorting will be done. Now, one more thing we can do. If we sort and if these numbers are more, for example, I can easily make it, let's say I can make all these numbers as 77777 and in the end I put 25. If that was the case, then you will have to try everything before you reach to 25. One slight optimization we can use is we can discard duplicates. Discard duplicates from nums. So if there are duplicates, that will give us some sort of saving. For example, here also you can notice that 2 is 2 times, 3 is 2 times. So what is the thing that we use to discard duplicates? Set. Yeah, but here we have to count also how many numbers we are discarding. So if 2 is occurring 2 times, we will check with 2 once, but we will also count that 2 numbers are discarded. So there it will be used as, so you will use a map. Yeah, 2 is used 2 times. So, and 3 is used 2 times and 4 is used 1 time. Now you can try these unique values one by one. If 2 is not GCD of 2 and the GCD of the array, then you know 2 numbers are discarded. So you will use this frequency for counting. So yeah, so a map will be combined here to do the counting, and map will also help us reduce doing the GCD search for duplicate values. So it will save some processing for us. Okay, so this was the last question. I felt this was kind of easy question rather than qualifying it hard, but I don't know. I coded it in C++, got it accepted, although this looked like very naive approach that we are finding GCD of this and then we are trying linearly for every unique query here. We are linearly searching if that is the GCD of array, comma, this number, that is the answer. So I did not find like this problem to be very hard today. So I don't know if getting it accepted was a result of C++. Usually C++ is faster. So sometimes even less optimized solution get accepted with C++ while they fail with Python and Java. Of course, for that, I'll also have to look at other people's solution. What were the other approaches they tried? Okay, but yeah, calculations wise, this was beating the constraints that they had given. Constraints were not very like, I think this was, the GCD works in some logarithmic complexity. So this was just trying to figure, like looking like it will meet the bar. So I just went ahead and coded that. Okay, so this was our fourth problem.